All right, so we started this before we wrote the test, solving when we had to put in identities. I just wanted to give more examples. So we went through the Pythagorean theorem identity, which is the sine squared plus cos squared equals 1, and we went over how we could rearrange it. So we could go sine squared x equals 1 minus cos squared x. We went through cos squared x. You remember this when I was wanting to subtract them. It was an addiction of the day. And I brutalized them, so I'm starting over. We're going to forget about that day. That day didn't happen. I don't know what you're talking about. I didn't save the recording. Then the next one, if we want to get tan by itself, we can go tan squared x equals secant squared x minus 1. Or we could get 1 by itself, and it would be secant squared x minus tan squared x, which usually you don't do the replacement of the one with secants and tans, but you could. And then we have cotan squared x can equal cosecant squared x minus 1. Or 1 can equal cosecant squared x minus cotan squared x. The other formulas we use as well are the other ones on our formula sheet that we've talked about in chapter 4 already. So we talked about cosecant theta equals 1 over sine theta. We talked about secant theta equals 1 over cos theta. We talked about cotan theta equals 1 over tan theta. But sometimes it's actually more helpful to say cotan theta equals cos theta over sine theta. And sometimes it's more helpful to say tan theta equals sine theta over cos theta. And how do we know which one is more helpful? Well, we're going to actually look at the question. When we look at the questions that they ask us for today and tomorrow, and for the rest of the unit technically, we're going to look and say, hey, do we need a cos to cancel off the denominator? Yeah, then I'm going to use the cotan, because then the coses will cancel. Okay, I'm going to use this cotan, not the 1 over tan. Right? So that, or do I need a tan to cancel off? Well, then I'm going to switch the cotan to 1 over tan so the tans cancel. Right? So you have to look at what else there is there that we need to go away before we do that. All right? Then we went over the double angle identities. I put the tan 2x one on here. It's not often used to replace because it's kind of uglier than the tan 2x, but remember we can't factor with the 2x, right? We can't factor if it's sine 2x, cos 2x. We're always going to have to replace those. The cos 2x ones have 3 options, but we went over this before. Certain ones are better to use. So if I have like a cos x, I'm going to replace it with the 2 cos squared x minus 1 so that I can just factor it, right? So here it says, to solve some trigonometric equations, you need to make substitutions using the trigonometric identities off of your formula sheet from the formulas we looked at in chapter 4 and found above from chapter 6. This often involves ensuring that the equation is expressed in terms of one trigonometric function so you can factor. However, sometimes only a GCF is required. So sometimes you'll make sure that both of them have a cos in it, both terms, and then you can take a cos out, right? Which we're going to go through the different types. Remember that every solving equation question can be verified graphing using your calculator, right? So the moment you have something equals something with one variable, you can go y1, y2 and check it. Now if they say algebraically and you do y1, y2 and check it, you get nothing, right? If that's all you did, just give the answer off your calculator and it's algebraically, you're getting nothing. So, we're always going to do example A together. You're going to do example B. We're going to do example A together. You're going to do example B. Okay? So, example A has 1 minus cos squared x equals 3 sine x minus 2. When it's a basic sine or a basic cos, we can't replace those with anything, right? We'd replace them with 1 over cosecant or 1 over cotan or 1 over secant, which would not be helpful. That would make it way worse. So, the only thing we can replace in these instances is the cos squared x, correct? And we went over one just like this. So if it has a minus sign in front of it, you're replacing the actual cos squared x, correct? Not the minus cos squared x. So the formula we use is the sine squared x plus cos squared x equals 1 formula. So if I want to get cos squared x by itself, I would have cos squared x equals 1 minus sine squared x. want to make sure I was actually recording. So I'm going to replace cos squared x with 1 minus sine squared x in brackets. What do I have to do next? Make sure I put brackets so that I distribute that minus sign, right? So I'm going to get 1 minus 1 plus sine squared x. Now, if you forget to do this distribution, you're going to have minus sine squared x instead of a plus sine squared x, and it's going to be bad, right? So we have to make sure whenever we substitute in, we put our substitution in brackets. Sometimes you don't have to distribute, and we can just drop the brackets right away, but often we're going to have to distribute. And then it equals 3 sine x minus 2. And so now I have sine squared x equals 3 sine, oops, forgot the 3. 3 sine x minus 2. What do I have to do next? I have a squared, so I have to move everything to one side set equal to 0 every single time. So I'm going to subtract them over, so I'm going to get sine squared x minus 3 sine x plus 2 equals 0. And then I say, what times what? Or I can actually, sorry, I go let m equal sine x, because you guys usually like that. So m squared minus 3m plus 2 equals 0. And then I say what times what equals 2, what plus what equals negative 3. What's it going to be? Negative 2 and negative 1. And I don't have to do decomp because I have a 1 in front of my m squared. So I get m minus 2, m minus 1 equals 0. So m equals 2, m equals 1. So sine x equals 2, sine x equals 1. Then I solve them separately. Sine x equals 2. Where is it equal to 2? It's no solutions, right? Because sine x is down here, and then 2 is above it, a horizontal line above it, right? So if I went y1, y2 with this one, I get a graph sine x, and then a line of way above it, because sine x maxes out at 1. So you have no solution for this one. Remember, extraneous happens when we get a solution and it doesn't work. We plug it back in and it doesn't work. No solution means I can't even find one to not get to work. And then sine x equals 1, where does that happen at? And sorry, these are for 0 to 2 pi, the domain 0 to 2 pi. So sine x equals positive 1 here, because that's 0 and 1, which is? That's my one solution. So we did the one just like this, right, in our practice. You guys are going to do B. Try it out. So this one we're replacing the negative sine squared x. So we're going to get 2 cos x plus 1 minus, and then the sine squared x is 1 minus cos squared x when I rearrange the formula, right? Equals 3. So I get 2 cos x plus 1 minus 1 plus cos squared x minus 3 equals 0. I'm just moving it off one side at once. So I get cos squared x plus 2 cos x. Those cancel. Minus 3 equals 0. Let n equal cos x. M squared plus 2m minus 3 equals 0. M plus 2, or sorry, m plus 3, m minus 1. So m equals negative 3, m equals 1. Cos x equals negative 3. Cos x equals 1. This is no solution because cos x mins out at negative 1. And this one, where cos x equals 1, is here. So the problem with that is we have to go and actually look at the domain. Does the domain include 0? Is there an equal to sign up in the domain? Yeah, but does it include 2 pi? No. So my only solution is 0. Make sure you watch your domain. Look at the restrictions, right? Okay, we're going to look at this one. This one, you're going to have to spot that it's a cos 2x, not a cos squared x. And you're like, of course it's a cos 2x, not a cos squared x. Of course it is. However, if I gave that on a test, a lot of people are like, okay, it's cos squared x. I just solve it like normal. It's not cos squared, it's cos 2x, right? So I need to go to my formula sheet. And I look at my 3 cos 2x's. And I want the one that only has whatever the heck other thing I have. So I have a cos x here. So I want the one that only has cos x's, which is 2 cos squared x minus 1, right? So I'm going to replace this with 2 cos squared x minus 1. Why am I not putting it in brackets this time? And I told you to always put it in brackets. Are there any signs in front of it? No. Are there any numbers in front of cos 2x? No. So if I put it in brackets, I could just drop them right back off. So you can do that. If this was like a 2 cos 2x, then I'd have to put a 2 in front and distribute it, right? So you have to watch yourself when there's a coefficient. Plus 1 minus cos x equals 0. The ones cancel. I get 2 cos squared x minus cos x equals 0. No idea. Let m equal cos x. So I get 2m squared minus m equals 0. Now this is what you have to spot. These are the ones that people get wrong, and they're actually the easiest ones. Did it just disappear on you?
Yeah.
So we have 2m squared minus m. Now this is where people go wrong. They'll move the m over, and they'll divide by the m, and they'll do some crazy crap to it. I just put crazy crap. I just said it twice. Craziness. I know, I'm sorry. It's too late to apologize. It's too late. All right. So what can I take out of this one? An m. GCF. GCF. And what someone did last year, always remember when you're stuck, GCF, God comes first. Ah, that was genius, right? Right? They were so smart. Well, it wasn't needing to rhyme. It's an acronym. God comes first. GCF. I'm not going to remember it because it doesn't rhyme. Yeah, if you're at your worst, God comes first. There, she helped you out. See, that's why we have Alex here. She's not just brains. She's not just brains. Well, no. That rhyming? Then I'm a genius in English because I can rhyme like no one. I'm a poet who didn't know it, you know? Like that's how I did all of my poetry. I was brutal. I was like, they're like, it doesn't have to rhyme, Crystal. And I'd be like, but it does. But it does. You know? And they'd be like, poetry can just be like a nice, I'm like, no, it has to rhyme. Like, if I were from Brooklyn, my name would be Brooklyn. Yeah. Yeah, like that. This is a really eventful podcast. This is what this is. Sad. Okay. So what was your thing?
If you're at your worst.
If you're at your worst, God comes first. So if you're like, I don't know what to do, GCF. Yes. Okay. Put an M. And we get 2m minus 1 equals 0. And not only does that work in math, that works in life. Genius. That's what she is. All right. So we get m equals 0. 2m minus 1 equals 0. 2m equals 1. M equals a half. So our m is cos x. So cos x equals 0. And cos x equals a half. Before I move on, I'm going to go, what is my domain? Oh, it's 0 to 360, not inclusive of 360. So cos x equals 0, right here, and here, which is 90 and 270. Don't all answer at once. Out of control. Slow it down. Okay. And then we need cos x equals a half. Cos x equals a half at 60-degree reference angles, and cos is positive here and here. Or we can just look up our unit circle, which is 60 and
300.
Thank you. You know, you're selling it. You're bringing it home. Thank you. Thank you. So x equals 60. This is a habit I have. I like writing them in order. It's not required. It's just my thing. 60, then 90, and it bothers me when I don't. 270, 300. Boom. Drop the mic. You're on B. And go. Not legit. Sine 2x, we only have one option. We can replace it with 2 sine x cos x. Now, if this is overwhelming, you can go let m equals sine x, let n equals cos x. I don't have to make this any prettier because actually both of them have a cos x in them, right? So as long as both terms, or all the terms have, if they mismatch, right? So this one we have one with a sine x cos x, one with a cos x. As long as all of your terms contain one trig ratio that all of them have, you can GCF that out, right? So we're in a good state. So we're going to go 2mn. You could have just left us in sines and coses if you can work with that. Equals 0. Then I can take an n out, right? And then I'm left with 2m minus 1 equals 0. So I get n equals 0 and 2m minus 1 equals 0. I find when they're like this, it's easier probably just to pull a cos x out and not replace them with m's and n's, but you can do what you want. Okay? So then this one I'm going to get m equals a half. So now I have to find when cos x equals 0 and when sine x equals a half. And once again, it's still in the domain 0 to 360, non-inclusive of 360. So cos x again is at 0. We already found this one, last one, which was 90 and 270. And then sine x equals a half at 30-degree reference angles, and sine x is positive here and in here because of cast. So some 30 and 150. So we get what? X. So I always go back at the very end and I go and check what variable they gave me, right? Sometimes it's theta, sometimes it's x, sometimes it's whatever. I go back and look and I say, oh, it's an x. Okay, good. X equals 30, 90, 150, 270. Okay? And we're going to flip over. Everyone has it. So, they get more complicated. We have a cos squared x, we have a cotan x, we have a sine x. For me, when I have single ones like cotan, cosecant, secant, unless I have like a cotan squared or a secant squared or something like that, I'm like, go away. I don't like you. That's what I think. Okay? So if I had a cotan squared, maybe I wouldn't get rid of the cotan, because I'd have cotan squared, a cotan x, and I could solve that, right? I could solve that. That's fine. But I don't have a cotan squared. So I'm like, you go away. So I'm going to go cos squared x equals, and then cotan I can replace with 1 over tan. Would that be helpful in this situation? Probably not. Or I can replace it with cos over sine. Would that be helpful? Yes, because the sines are going to go away. So I can go cos x over sine x times sine x. Now this is my problem, guys. I have a denominator. In my denominator, I have a variable. Remember rationals from last year where you'd have to like factor the top, factor the bottom, factor the top, factor the bottom, multiply them, cross them off, write NPVs, all that jazz. Long shabazzle of rationals. The reason why we had to write NPVs is because we had a variable in our denominator. And our denominator can't equal what? What can't be in our denominator? 0. It was so illegal. You would get like a math ticket. And it would be like a $10,000 math ticket. It's that illegal. Okay? Brutal. That's what it is. So, the moment I actually end up with a variable in my denominator, doesn't matter what unit we are in, we have to state non-permissible values. Because there's a variable down there, and where it equals 0 can't happen. Okay? So, I have a sine x in my denominator. So I'm like, no. So I have to find out where that would equal 0. How do we do that in rationals? We went like x plus 2 cannot equal 0. X cannot, what is the light and why is that? You stop. They're like, it's like worse than a feather. They literally can't pay attention. It's like a light on the roof and they're like, what is that? No. If I could drop the feather from the roof, you'd all be like, that's what you do. So they can't help it. And whatever watch thing that you caught some of the bright lights from, like you, like, yeah, right now you're like shining. You shine bright like a diamond, you know? Shine bright like a diamond. Okay, sin x. They're going to pull this off of YouTube because I sound so much like her, they're going to think I stole her music. It's going to happen. It's going to get pulled off. So you might want to watch it really fast because I think that's going to happen. So we would say if we had an x plus 2 can't equal 0 in the denominator, then we'd say x can't equal negative 2, correct? So whenever we have a variable in the denominator, we have to stop. Oh, you don't know this. It would have been funny if you did. Stop. Hammer time. Yeah? Someone know that? Thank you. You do? You know, I talk about the Simpson episodes from way back when, and no one knows, but hammer time. I'm glad. Okay, good. So we have sin x, and we have to say it can't equal 0. Because if it did, we get a math ticket from Mrs. Lepp, like for $10,000, $1 million. Yeah, you don't state your NPVs. I'm going to literally type a math ticket up and paste it onto your unit test. It's going to be worth a chocolate bar. I don't even like chocolate bars. It's going to be worth ketchup chips. That's what it's going to be worth. You're going to owe me a bag of ketchup chips, and it can be a Halloween-sized one. I don't care, but you're going to owe me to me if you don't say NPVs. It might be a drawn ketchup chips on a piece of paper. That would work as well. I'm just saying there's options. But you're going to owe it to me. I might make it different things, like a drawn bag of ketchup chips. Mrs. Lepp drawn teaching, you know? It's going to be fun. I'm going to hand out tickets. I hope to hand out none. I hope you all get this right. So we have to find out where sin x equals 0. Where does sin x equal 0? Yeah. 0, 180, 360, da-da-da-da, ba-da-ba-da, negative 180, negative 360, ba-da-ba-da, da-da-da-da. It keeps going, right? So we have to actually state non-permissible values, but we have to state general solution non-permissible values. So we're going to say x cannot equal, and remember when I say general solutions, I start with my very smallest principal angle. So my very smallest angle that fits on the unit circle. So it's the very smallest angle that fits on the unit circle for this answer. 0. And then I'm going to go plus. How much does it take me to get to the next one? 180. So these ones actually can work together, right? I could go 0 plus 360 n NEI, 180 plus 360 n NEI, but it's being redundant because you're kind of getting it in the next one anyways, right? If you did that, you wouldn't be wrong. It wouldn't be a multiple choice answer, though. On written response, be okay. So you have plus 180 degrees n, and then I follow with NEI. We agree? Do I have to write the 0, though? So I show the 0 degrees. Ooh, that's radians. But I don't actually have to write it, so I can go 180 degrees and NEI. So that only works when my principal angle, my very first angle is 0, right? I don't have to write it. Could I write it, though? Absolutely. So I say to my NPVs, why are these important? Because at the end, if I get an answer that's 0, 180, 360, negative 180, any of those, I say extraneous. Because it can't be that, right? We always have to check our restrictions at the end. All right. So we got to this point, state our restrictions. Now we can cancel. You can only cancel after you state restrictions. If not, you have to like go, stop it, state restrictions. You slap your hand and you be like, no, no cancel, no cancel until I state that. So now I have cos squared x equals cos x. Then what can I do? Whenever I have a squared, no matter what I have with it, I have to what? Every single time. Move to one side, set equal to 0. That's my only rule, right? If I have a squared, everything goes to one side equal to 0. If there's no other options, I can't divide by a cos, because some people try and do that. Nope. If I have a squared, everything one side equal to 0, I have no other options. Cos squared x minus cos x equals 0. Then what can I do? I can replace if I want. Let m equal cos x. So I get m squared minus m equals 0. And if I get stuck, I do what? If I'm at my worst, God comes first. So what do? Take out a m. See, now it's going to stay. You're going to be in my memories for life, Alex. It's never going to go away. It'll be part of all my memories every year. Because I remember who said God comes first, and then they think in my head, and then I'm like, oh, I remember them. And the people who came up with, like, tan your Xbox, I always think of them every year, too. So m equals 1. And then I get, she's like, I don't want you to think about me, but I will, in a fond way. Like, she's so smart. Look at her. She came up with this. Okay. Where does cos x equal 0? Where x equals 0. It's literally been every answer we've had so far. 90, 270. Are either of those in my MPVs? Nada. So they're good. I like them. Wait a second. It's still in, the domain's in degrees. I thought for a second it'd be in radians. And then this is 180. That's not 180. That is a lie. A lie. 270. And then we need where cos x equals 1, which is, bam, right there. So I'm going to give myself those solutions. I'm going to go 0, 360. Oh, wait, it can't include 360 because that's not inclusive. It can't include 360. And I write 0, 90, and 270. Yeah? No. You say, nah, not today. Because it can't equal 0. Can't equal 180, can't equal 360, can't equal any of those, right? This one's actually out too. So this one, x equals, is it x? Yep. X equals 0. I actually circle it, put a line through it, and I say extraneous. Because I want to be like, not only am I like not going to write as a solution, I'm going to show the people marking this that I'm a freaking genius. Like, not only do I have the right answers, I also have the non-permissible values, and I'm showing you the extraneous root. Like when we mark this, or I mark this, I'm just like, be still, this is like, I want to take a picture, and I want to hang it on my fridge. It's so beautiful. That's how it is. Like, you guys hang children, well, you don't, but like, that's weird. Your parents hang like children, like you.
That's not better.
That's not better. Your parents hang you on your fridge, or like your test, or like, yeah, they don't hang you either. Oh, this is going so badly. Your parents hang pictures of you. Thank you. Wow, that just really took a curve for bad things. I want to hang hang up on my fridge this answer because it's just so beautiful. You know, well, not yet. I want to hang up on my fridge this, and I would have to hang it up with tape because I have. Stainless steel fridge. And I would take the tape marks. I would take a hit of the tape marks on my fridge for this question. It's so beautiful. Magnets don't work on stainless steel. They only work on the side of the fridge, and my fridge is a double fridge freezer combo, and it's like, it's encased. It's encased, so I have to put tape. And I would tape. I would tape and take the tape marks that would be left behind, which would kill me inside a little bit. But that's how great this question's answer is. So let's see if B, you can do it. If you solved for sine, I don't know what you're saying.
Like substitute cos x squared for 1 minus sine x squared.
And then solve.
Substitute cotan squared for cosecant squared or 1 minus.
If you went and like replaced a whole bunch of stuff, yes.
So it's still the same.
Yes.
Oh.
It would just take a
Maybe.
longer time. But yeah,
Okay.
you would. And you'd have more MPVs,
Yeah.
right? Which would end up resulting in the same ones because cosecant is besties with sine, so I get the same problem.
Mm-hmm.
So you're fine. But you'll be solving more. Yeah. But you sort of result in the same MPVs, which is you do more of them to get the same ones.
Yeah.
Yeah. Okay, you guys are trying out B. As I like to call it, B. Hint, hint, to replace the tan. This is something to note as well. If all you have is like tan squared plus tan x minus 2 equals 0, let's say, right? They're all tans. You still have to watch out you have non-permissible values. Why? Yeah.
Because you could possibly get a sine value that's in the non-permissible value.
Right. So when you do tans, when it's tan straight across the board, remember that tans are divided by cos, correct? Tans are sine over cos. So it's where cos x tan equals 0. But also, remember, what about tan graphs? Tan graphs have asymptotes, right? They have values where x don't exist. Yeah. Which is at 90 and 270, right? All those ones. So remember, whenever you're doing tan solvings, even if it's plain old tan squared plus tan x plus whatever, you have non-permissible values at the 90s and the 270s, right? And everyone thereafter. So 90 plus 180 and NEI, right? So these ones are more obvious because you're literally going to have something sitting in your denominator, because I'm going to go sine x divided by cos x, correct? But when you have plain old tans, you don't even think about it, but you still do have non-permissible values with tans. All right. So we have sine squared x equals 1/2 tan, which is sine x over cos x, times cos x. And then I'm going to cross off my cos x, because that's what I want to do. Before I cross it off, I have to state restrictions for non-permissible values. So everywhere where cos x can't equal 0, so that's at 90 and 270. So I could go 90 plus 360 and NEI, or I could go 90 plus 180, because these keep happening, right? So I'm going to go x can't equal 90 degrees plus 180 degrees and NEI. So I'm going to get sine squared x equals sine x technically over 2. Because multiplying by half is like just putting the 2 on the bottom, correct? How can I get that 2 to go away? Times by 2. Now I have 2 sine squared x equals sine x. Something is squared. When something is squared, I need to move everything to one side set equal to 0. It's not even an option, right? That's just part of our beings at this point. We were taught it last year. 2 sine squared x minus sine x equals 0. Then what can I do? Take out a sine x. So I can replace them if I want, or I can just take out a sine x, right? I don't replace personally, but I'm going to keep replacing just in case you do. If you don't replace, you can take a sine x and do it that way as well. So I'm going to go 2m squared minus m equals 0. Take out an m. I get 2m minus 1. Now you guys, please watch. Everyone will go minus 1, but if it would happen to be this instead, 2m plus m, people will go m and then 2m and then they make it go away. Remember, when you're taking a GCF out, you're just literally simplifying. So however many terms you had in the first place, you still have to have. So if I take an m out of 2, I have to have 2 left behind, right? Because a GCF just means I'm simplifying it. I'm taking something out, but if I have 2 terms, I still have 2 terms. Okay? So now I have m equals 0, 2m minus 1 equals 0, m equals 1/2, and m is sine x. So sine x equals 0, and sine x equals 1/2. Sine x equals 0 when y equals 0, which is here and here. Are either of those my NPs? No. So 0 and 180 and 360, but 360 is not inclusive, so I don't add it. Sine x equals 1/2 at the 30s, here and here. So 30 and 150. Are any of those non-permissible values? No. So I always have to check at the end if I have non-permissible values that my answers are not that. If they are, I circle it, I put a line through, and I say extraneous. If you do these perfectly on your tests and stuff, I'm literally going to take a photocopy of them, and I'm going to post them on the backboard, because I'm just going to be that proud. Okay. So, x equals 0, 30. Some people post pictures. I post math. Beautiful math. One person last year had notes so nice that I legitimately wanted to, like, they were prettier than typed. Like, if you typed up notes, they didn't look as pretty as that person's notes. It was just like, she opened her book and it was like sun, like the light shone through it, and it's like, ah, and then there were her notes. You were like, oh my, girl. Beautiful. All right. What's going to happen here? Sine 2x, we don't have an option. We have to replace with 2 sine x cos x equals the square root of 2 cos x. Now, why would I put this one on when it looks a heck of a lot like the others? Because people are going to try and divide the cos x. Because it's not squared, you're like, dude, I don't have to move it to one side. But what happens, what has to come first? We have to move all of our squares over, but also we have to think of God. And he comes first. And so, in this case, we have to GCF. Do not divide by cos x. You should be smited if you do. Like, you should, like, it's like, oh, smite. No, that's a little harsh. Okay. You should get, like, it should, like, I wish your pen got repelled when you did something like bad. I mean, you did bad math, like, jumped away, and then you're like, okay, pen. Right. Like, if you went to go, like, try and divide, your, like, pen would, like, you'd be like, all right, can't do that. Oh, no. Mask for the marker. That. You know, wouldn't that be cool if, like, you like tried to do some math and it smited you? Well, it didn't smite you. I have to quit using that. It would like repel, like it would like fly off. You know? Wouldn't that be amazing? Well, it would be really frustrating if you never could figure out what the right thing to do was. Your pen just kept flying off your page. You'd be like, come on, just let me do this. All right. So then you'd be like, no, I can't divide. That's brutal. I have to subtract it over. And God come first. So that's what I have to do. When in doubt, GCF it out, you know? So we take out a cos x, and we're going to be left with 2 sine x minus root 2. Could I replace cos x with m and sine x with n and do it that way? Yes, please. If this is confusing to you, what I just did, be like, no, not today, Lepp. I'm m and an n. Okay? Then I'm going to have, so I can do that, or I can let m equal sine x, let n equal cos x, and I can go 2mn minus root 2n equals 0. Take an n out. 2m minus root 2 equals 0. N equals 0. And then 2m minus root 2 equals 0. 2m equals root 2. m equals root 2 over 2. And then n is cos x. And then m is sine x. Did I have any denominators or anything here to get me NPVs? Nope, I'm good. Cos x equals 0 here and here. Literally, this has been like the answer of the day. Cos x equals to 0, right? Like that baby's coming up 27 times. Not really. This might be a little over exaggerating. Root 2 over 2 is 45, and it's positive, so it's here and here. 45, 3, 135, 3, blah, blah, blah. Yeah, that. So x equals 45, 90, 135, 270, monotone. Good answer. Pardon? Well, you know, Lepp should read. Ooh, and in degrees. I typed this. I should know this, but I did not read. General solution. So, it's a lovely solution. It's great. I boxed it. I shouldn't have, but it's lovely anyways. Nonetheless, it's pretty. It wouldn't make it on a board because I didn't answer it right, and I would have lost marks. Still pretty. But we can go 90 plus 360n NEI, 270 plus 360n NEI. We could do both those separately, correct? Or we could lump them together and say x equals 90 plus what? 180 degrees n NEI, because they happen every 180. Or I could write them separately and not be wrong, right? I could go 90 plus 360 n NEI, 270 plus 360 n NEI. This one, I'm going to do, I can't put these together, right? There's no way. Some people try and go like 45 plus 90, but then it would be every 90, and I'd get arms down here. And do I have arms down there? No. So I have to do these ones separately. So it would be 45 plus 360 degrees n NEI and then 135 plus 360 degrees n NEI. Okay, then we're going to flip over. There's another one, but we can do that later. You can try it on your own. Now, could we check these? Remember, we can always go y1 sine 2x, y2 root 2 cos x, right? And then find out where they intersect. We could absolutely check these in degree mode. Okay. It should be my last one, isn't it? Yeah. Okay. So 2 sine x equals 7 minus 3 cosecant x. So I can't use Pythagorean theorem identities. I don't have squared. Can't use any of the sine 2x or cos 2x identities. Don't have that. What's the only thing I could change here? Cosecant 2, 1 over sine. So I'm going to get 2 sine x equals 7 minus 3, and then 1 over sine x. And before I move on, I'm going to stop immediately and be like, dude, I have a denominator with an x in it. What must I do so I don't get a math ticket to give Mrs. Lepp a ketchup chip bag? NPVs, restrictions. So we're going to go over here and we're going to go restrictions. See how I put it in red for like the red ketchup bag that you would have to give me if you don't state your restrictions? Might be drawn on a sticky note. I don't care. I'm getting one. So we're going to go sine x cannot equal 0. Where does sine x equal 0? 0, here, here, here. It keeps going, right? And my domain is negative 180 to 180. So I'm going to go x cannot equal 0 degrees plus 180 degrees n, NEI, or I could literally just write it as 180 degrees n, NEI. So if it lands on any of those, it's extraneous. It's out. I circle it, put a line through it. We want to make Mrs. Lepp's don't know what's going on. Back wall cover. All right. So, it's so loud. So, we have a sine x in the bottom. How can I get rid of that bad boy? It doesn't cancel. So what could I do? Multiply everything by sine x. If you had a 2 on the bottom, you'd get rid of it by multiplying everything by 2, correct? If we have a sine x in the bottom, we can multiply everything by sine x. So I'm going to multiply this by sine x. Each term. This by sine x. This by sine x. So that cancels. And we get 2 sine squared x equals 7 sine x minus 3. And now I have just a nice little decomposition going on, right? I have a squared, so I move everything to one side. So I get 2 sine squared x minus 7 sine x plus 3 equals 0. Let m equal sine x. So I get 2m squared. I really hope that I've been recording this. Minus 7m plus 3 equals 0. Now what multiplies to give me 6 and adds to give me negative 7? Multiplies to give me 6, adds to give me negative 7. Negative 1 and negative 6. It's decomposition because I have a 2 in front. So I'm going to go minus 1m minus 6m plus 3 equals 0. And then I group the plus sign in between. So I take out an m, and I'm left with 2m minus 1 plus a 3, negative 3. Take out a negative 3. I'm left with 2m minus 1. So I get m minus 3 and 2m minus 1 equals 0. I get m equals 3, m equals a half, and m happens to be sine x. So sine x equals 3, and I get jump for joy whenever I see stuff like this because it gives me no solutions. And then sine x equals a half. Now these ones have to be from between negative 180 and 180. This one gets me no solution. When it's a different domain, I still find on my normal unit circle, right? And then I just find the coterminals. That's all I do if it doesn't fit. So this one happens to fit. So 30 and 150. Will its coterminals fit between negative 180 and 180? No, they'll be too big or too small. So my answers are just x equals 30 and 150. So I gave you a type of each. This one's the same thing. I would change the secant to 1 over cos, state where cos can't equal 0, right? Which is 90 and 270. And then I multiply them all by cos, which would get you the same deal, right? So I gave you one of each different kind of type that I see, where they're a little different, where you replace sine squares, or you replace cos squares, or you replace cos 2x's, or you replace sine 2x's, or you replace secants and cotans and tans and they cancel, or you replace them and they don't cancel, and I have to multiply by them all. Okay, those are all the different little types that I've seen. And that is your homework.